Okay, question 7, we've got a picture of two curves, and it starts off just by asking us about our transformations, which you need to learn. So, part 1, we're going from square root of x, y equals square root of x, to y equals 1 plus square root of x. So we've got a plus 1 here, so that's going to be a translation. Okay, what has happened? Well, it's not in the square root of the x, that means y has changed. So y has gone to y minus 1. So we get y minus 1 equals root x, that's what's changed about it. So that's a translation in the y direction, 0, 1. Next one, we've got y equals 4x to y equals 4x over 9. So x has been replaced with x divided by 9. So that means it's a divide or multiply, so that means it's a stretch. So we have a stretch. Which direction? Well, it's on the x. The x has been replaced. So it's parallel to the x-axis or the x direction. Okay. Now x has been divided by 9, which is the same as multiplying by a ninth. That means the scale factor is the reciprocal of a ninth, which is 9. That's just a straightforward knowledge. You need to learn your transformations. Right, then we go on to the second bit. So part B, let's do that in a moment. Okay. B part 1, they've told us something, they've given us one integration and they want us to find another integration. Now you could just put this in your calculator, but there is a way to work it out. So the integral between 0 and 9 of 1 plus square root x dx, remember that's the same as the integral of 1 between 0 and 9 plus the integral of square root of x. So the integral of the square root of x they've told us is 18. Now if you're going to integrate 1 between 0 and 9, there's a couple of ways to think about this. One way is to think about what integration is finding. Okay. So integration is finding the area under the graph, which in this case is the line y equals 1 between 0 and 9. So you can see it's a rectangle, so that's going to be 9. Or the other way is to actually do the integration. So 1 integrates to x between 0 and 9. If you substitute in 9, substitute in 0, you're going to get 9. So the answer is 27. Just writing down 27 would get you the mark, as it's only 1 mark. Right. Then we're going to move on. So that was a little thinky thing. Interestingly, that did then come up, a similar style of question came up in Core 3 the next year. So it is a good technique to practice. Now it's asked us to use the trapezium rule. So trapezium rule is on page 8 in your formula book here. Or you can just remember it. You need to remember what this means. Okay. So step 1 with the trapezium rule is it told us 5 ordinates and we're going between 0 and 9. So we need to work out what our step size is, which is our h. So that's 4 strips. So I take the line between 0 and 9, divide it into 4, work out the numbers in the middle. So it's going to be 4.5, 2.25, and then 6.75 to make that an even split. As you can see, I've now got 5 x numbers, which is going to give us 5 ordinates. Then you can just use your calculator. So these are going to be our x values. Okay. And we can use table mode in the calculator to find our y values. So go to table mode, type in our function, which is the one we've been given, we're trying to integrate. So 4 to the power of x over 9. You can do this by hand as well if you wish. We're going to start at 0 and we're going to finish at 9. And our step size is what we just worked out, so that's 2.25. So it's going to give us tables of values, and we can use these to fill in our table here. So they want 1 decimal place, so let's make sure we're working to at least 3 decimal places in our table. So 1.4142. You do need to check these because they don't round, they just truncate. So then we've got 2.8284, and then if you scroll down, get 4. Right, once you've got your table of values, I'm going to use the trapezium rule, which as I said was in your book. So the trapezium rule here says that the integral is approximately a half times h. H is your step size. Okay, so that's 2.25 times. Okay, y0 means the first y, so that's 1. Yn means the last y, so that's 4. And then all this stuff in the brackets means 2 times all the y's in the middle, so the ones I haven't used yet. And then if you put all of that into your calculator, if you put it in just like that with those brackets where they are, you will get the right answer, which tells us it's approximately 19.67085. And then we look at the question. Okay, back to the question. It said 1 decimal place, so that's 19.7 to 1 decimal place. Okay, so I've just cleared up the board a bit there. Then we can have a look at part 3. So part 3 wants us to find approximate value for the area of the shaded region, which was in the question, and whether this can be over or underestimate. Right, so let's have a look at what we've got. So in part 1, we've worked out the area under the curve 1 plus root x. Now that's the top curve. So it helps if you can recognize your curve. So that's the curve y equals 1 plus square root of x. Square root of x graph goes like that. So we know the area under there is 27. Okay? So shaded area is going to be 27. So that gives us all that area. Now the bottom curve is the curve y equals 4x over 9. And in part 2, we worked out that the area under that curve there, so this area here, is 19.7. So if I take that away from the answer for the top curve, we're going to get an approximate for the shaded area, which is going to give us 7.3. So that's the first part. There's an approximation. Now, why is it approximation? The answer to part 1 is accurate, and the answer to part 2, the 19.7, isn't accurate. It was an estimate. It was the trapezium rule. So if we have a look at this curve, we need to work out if our trapezium rule was an under or over estimate. So if we draw trapeziums, for example, this isn't the, there we go, on this curve, and then join them up, what would happen, you can't really see it very clearly here, is this curve is curving down, so it's going to curve under. So that means our 19.7 is an overestimate of the area. So if you take an accurate answer, and then we've overestimated the area we're taking away, that means we've taken out some of this shaded bit, so our final answer is an underestimate. Because part 2, which was the trapezium rule, is an overestimate so subtracting this from the accurate integration will lead to an underestimate. Okay? 2 and underestimate. If you're not sure how to write something, a nice clear diagram also helps and could help you gain some marks in the exam.